So, good morning and welcome to the second day of the 30-second workshop. First speaker this morning is Torben Hoffman from Tolerant Solutions in Denmark.
Thank you. So I followed in the presence of a lot of functional programmers. I would explain how I got into Erlang first. First touch of Erlang was back in the late 90s. I was still in academia at that point, and I had a look at Erlang and I said, this will never work. It's got no typing system, because I came out of the ML school, so no types, cannot work. And then I was using concurrent ML for some of my research at that point, and then this bloody Erlang thing came along, and it did asynchronous message passing. That can possibly not work. And you can read about that in one of my old blog posts about how I was utterly wrong. And people that jump into Erlang these days will, some of them take the same wrong decisions. Hopefully they're more informed than I was at that point to take those wrong decisions, but you never know. Anyway, so after a few years, I was sitting in a middle management position in Motorola, and there was a long list of proposals to do some research together with universities back in the time when Motorola had money. So there was Mod Labs, and there was a weird guy doing something with Erlang, and I just set my big fat finger on that one. We do that one. Then 4 years later, the results came back, and at that point I had been doing people management, I'd been process improvement, technology stuff, all the kind of things that makes a good, healthy, upward trajectory career. And I just had to do something else, so I jumped on the Erlang bandwagon and said, Erlang, it has some potential to solve one of our big business problems at that point. So I circumvented, which is career advice, don't circumvent all the middle managers and go straight to the vice president. It will come back to haunt you in many years. But I went straight to the vice president and said, we are going to do this, we're going to use Erlang to solve your big business problem we've talked about. And he said, yeah, well, and we had some debates back and forth, and after a while he said, no, somebody else is doing this, but you guys, you go up and talk to the lead senior system architect, and you find something to do. We went on and we did something with Erlang. We created a product from scratch. I gave up all managerial roles and had the most fun and the most learning experience in my life. Also the most hard work ever. And we created a product based on Erlang from the scratch and actually shipped it to customers at the end. And then blah blah blah, rest is history. Now I'm CTO of Erlang Solutions here, and I'm here to talk to you about the golden trinity of Erlang. Fitting for an Erlang priest to speak about this. And why I'm doing this talk is, of course, to introduce you to the golden trinity of Erlang, because this is the important thing to understand about Erlang. So I'm condensing everything that Simon and Francesca has been writing big fat books about and turning that into a 20-minute rant here. And then I want to show the business value of these simple things and how that actually makes you money. And then, of course, being an Erlang priest, I need to spread the Erlang love at any occasion. So be aware there will be a lot of Erlang love in this talk. So just to say a little bit about Erlang Solutions, we have a lot of customers. And normally there's a number of reasons for it, but in fact there are 19 billion, no, billion is American, and millions of reasons to use Erlang. That's WhatsApp. That's Erlang combined with good engineers and some other good technology choices. That makes you a lot of money. So that these days, that ends all discussion of why use Erlang. Until you start talking to middle managers who will defend the Java armies to death. And we also have a lot of university relations where we're actively involved in a lot of research, and we continue to do that. So, then, in order to understand the golden trinity of Erlang, I'm going to take you through a little bit of Erlang history. Because Erlang is different from most other languages, because Erlang originated in a company trying to make money. And what Ericsson, that's a wonderful logo of Ericsson up there, what they wanted was they wanted short time to market. At the time when they were doing these pre-studies that turned into Erlang, they had turnaround times of like 3 years from when somebody got an idea or a customer voiced something to they had something in the field, even longer sometimes. They also wanted on-the-fly upgrades, because they had some very nasty customers who had that idea that, wait a minute, if the telecom system you deliver to me, if it's not running, I'm not going to pay you anything. And that business model, you also see that today when companies like Rolls-Royce, they're giving out, not giving out, they're selling their engines to airplanes. If that engine is not running, Rolls-Royce is not getting paid. It sort of makes people slightly committed to what they deliver. And Ericsson had the same issue with the telecom stuff. And then they wanted quality and reliability because, after all, this is telecom, this is communication, this is somebody's little mobile phone that needs to be able to call his girlfriend 10 times a day or something like that, very rare, and then some other stuff there. And but in fact, what they wanted was productivity. And you can also translate on-the-fly upgrades to no downtime. So that's what's and then they wanted something that always works. So these, just translating it slightly from the more technical things into more business-like things. Then, I don't know what it was, but all the managers at Ericsson, they've been young in the 70s, and they probably listened a little bit too much to ABBA. But what they really, really wanted was money, money, money. It's a rich man's world. And well, I'll make sure that it comes in. All of these things and the history behind this is described in Bjarne Dekker's Untitled thesis. And you should go and read that. That's a marvel piece about technology management, and it's very well read for this thesis. Now, and this, I have a thing about simplicity. So I have this from Hoare, that the minute the tool you're using becomes part of the problem, something is wrong. The basic tool you're using to create what you're doing should be simple. This is an insight that had been revealed in '81 when he had the Turing Award. Never let things like C++ and other hideous things, they are part of the problem. They should not be there. So there are things here. And Erlang actually has I'll get into why that is there. Then Erlang is good for more than telecom, because otherwise we wouldn't be having storage there. So if you have something where you have low latency over throughput, then Erlang is your friend. Also, if you have something that's stateful, so you have things like session where you keep data around, like when you have a phone call on the telephone central, or you have an exchange of messages in an IM system, then if you don't have state, you might consider doing other things than Erlang. You see, I'm not over-religious about things, despite being an Erlang priest. You have to know when to pick the right tool. If you have something that's massively concurrent, talk WhatsApp, they have so many things going on at the same time. If you need something that's distributed, not necessarily because Erlang has distribution in so you can wire up Erlang things, but because it's very good for doing protocols coming out of the telecom domain. And then if you need something that's fault tolerant, most people want it these days, at least if they want to be buzzword compliant. And something where it's complicated enough for you to use the OTP library inside Erlang. And if you need non-stop operation, then Erlang is also your friend there. And then one of the things here, because you see a lot of benchmarks out there, and this is one of our consultants who's working in a big Danish company, no, not big, a small Danish company. His discovery after a while is that when you put things on the load, Erlang performs as well as all the other languages, normally better, because it deals with being pushed a lot better than other languages. Good. Then, the golden trinity of Erlang. Now, if you have iPhones and things, you should be taking pictures and read it and everything. Erlang has 3 pillars that put together is the marvel of the engineering that goes into Erlang. This is the important part. You have share nothing, which a lot of people these days have come to realize sharing nothing is good. They have fail fast, something that hardware people have known for years, and then they've added failure handling. These 3 things, when you weave them in together the way it's done in Erlang, it's beautiful, it works. And I'll take you through each of them just to share, not to share. So, you're doing the regular stuff in a C, C++, whatever setting, you share some memory. When one process dies, well, the memory is corrupted. The only sane thing to do is to kill the other process. This is how Motorola did their mission-critical systems. So that meant when somebody was goofing off and making something go down, the entire zone controller, which is a telephone switch in these systems, had to be taken down. That raises alarms, because you have a standby thing, so it takes a while to get that up, but it raises an alarm. And that means that it goes through a chain of events, and after a few things, somebody in the States will be calling the manager in Denmark in the middle of the night, screaming that he needs to have somebody on site immediately, which is not what you want to do. Other companies will have similar stories about these things. So what you do in Erlang is you don't share any memory. So when P1 here dies, that memory is corrupt, and then you just wait for the garbage collector to come around and reclaim that memory. P2 is unaffected by it. So this is the benefit of share nothing. Lots of other people are realizing this these days and trying to build a system this way. Good. That was the garbage collector.
But they do share the same address space. I mean, they're in the same process, same Unix process.
They're in the same Unix process, but inside of that, they're all separated.
But so you're assuming that certain corruptions don't happen, like an Erlang process doesn't overwrite something.
And that's where the last 20 years of development of the Erlang runtime system goes to prove that that just doesn't happen there. But you're right, it's in the same Unix space, but none of this is shared. None of the processes, which is the building blocks of Erlang, share things. So, but you're true. So, in very grave events, you can have things taking things all the way down, but that is rare.
You also need a very reliable memory manager.
Yes.
The garbage collection has to be equally reliable. That's why most of the errors will come, I think, from that.
Yeah. Erlang is memory safe for the individual program. The individual programs, everything's checked.
Yes.
You can't do wild writes.
You can't go and fiddle with somebody else's memory.
Even accidentally.
Yeah. So that's a good thing, a very good thing. It helps you avoid a lot of problems. And then again, failures, and this is where again Erlang is different from other languages, is that all the things that can go wrong will go wrong. We all know that. If you're more than 27, you know that everything will go wrong. So you have programming errors. That you realize after you're 30 that you can actually make errors yourself while you're programming there. Then you have disk failures. This will happen. This will kill you. And network failures, even more so. Those things are just unreliable. So normal languages, they're fault intolerant. They don't really cope with faults. That means that you must deal with all the errors or die. It's a very mature world. Either you deal with it all or you die. Erlang, on the other hand, is fault tolerant by design. And that means that you embrace errors and you manage them, meaning that you can continue to live. And I'll show you a piece of code here of that brand. So this is the naive and not that it failed way of doing is here you have a converter between weekdays and the number of the day in that week. And here you have a catch-all at the end and say, error unknown day. Somebody gave me something wrong. This is not the Erlang way of doing it. You're just propagating that error outside. If somebody is stupid enough to call this function with something that's not something, he should be penalized and whipped immediately. So what you do in Erlang is you burn that code. And then you get this fail fast function. And that has the benefit when you do this consistently throughout your code base. When you have something that fails, the stack trace leads you to the bug in no time.
Static type, it would fail at compile time though.
Sometimes.
Sorry.
Yeah. True. Then again, this is a simple one where of course a static type system would have helped you quite a lot. If you're going to more involved stuff when you're doing something with protocols and have interactions, and then you, for some reason, you end up in a bizarre state you didn't envision, then this one is what saves you.
But then you need dependent types.
Yes. But you see, I still have my hair. There are two reasons for that. I don't do dependent types, and I don't do C programming. Those are the two things that keeps my hair on my head.
But I have a trick. I have an Edwin.
Okay. So anyway, and one of the things here is we had the system. We did this in Motorola. So we went to do these IOP tests with our competitors, and we were two guys sitting there doing everything: coding, system testing, everything. And they had an army of people. So they had 2 system testers. They had 7 engineers and 7 architects on this thing, all sitting outside the room waiting for things to happen. Then our system goes down. Boom. We have a look at it. And then the competitors like, and we just, okay, wait a minute. There's a bug. Okay, boom, boom. 20 minutes later, new version works. Then the funny part is, 5 minutes later, their system crashes. I could see that in my system, and they were just like, oh, it's not working. Yeah. And then I just went over, I had my stack trace, what went wrong, and went over to their screen on their debugging system that I'd never seen before, and I ran down the page and there's a bug. And they're like, what? that's a bug. So they had to call the engineers in. Okay, yeah, they admitted that's a bug. And then they had to go and fix it, and it took them 24 hours. There you go. Let it fail. And again, that means that Erlang actually encourages, I don't know what the right word for it is, but I like offensive programming. So, as opposed to being defensive about things, we're being offensive. You go for the golden day scenario all the time, and you worry about the error some other day.
Offense is the best form of talking.
Yeah. So anyway, so what would this be without having some numbers to actually show there's money in it? So this study that was done with Motorola, so here you have an existing component called data mobility that has been rewritten in Erlang. So here you see code that solves the problem. This is the app code in this graph. That's what solves the problem of the customer. This is what you're making your money off. So in C, you have a staggering 18% of your code base is devoted to solving the problem and the needs of the customer. And when you look at the libraries, it goes even more berserk. Then in Erlang, depending on what version you look at it, you end up with over 60% of the code devoted to solving the needs of the customer. This is money in the bank. This is fewer lines of code. You need fewer developers. Which comes back to the saying in the Erlang community, don't tell a manager of 10 that Erlang is 10 times as effective. Don't tell a manager that. He'll just be very scared. But here we have Erlang being 3 times more effective, more bang for the buck. So that's all. Well, now we allow ourselves to let it fail very fast. So how do we deal with that? So that's failure handling. And this is where the supervision hierarchy in Erlang kicks in. So here you have a number of supervisors. Those are the ones with 2 double circles. And they're monitoring either supervisors or workers with single circles here. And that means that if this poor guy down here dies, it's the supervisor here that deals with that error and takes appropriate decisions about what to do. This guy over here is not affected whatsoever by this. And this is how you build reliable systems in Erlang. You embrace the failures, you deal with them, and if you can't deal with it, you propagate it up. And then you can make more elaborate supervision and monitoring schemes depending on the needs of your particular problem. Now this is where some of the business benefits comes from. This weaving in of having failed fast with supervision. So the business benefits here are, you only have one process that dies when something goes wrong. This is really important, and that means that this isolation gives you continuous service. All the other guys are still running, which depending on your business could be very important. Then everything is logged in a sensible way. And that means whenever something goes wrong, you know exactly what it is. You have all the information. It's not like you need to do a CSI Miami and you need to hire expensive policemen or actors to come in and investigate your system. No, you know what's wrong. And that means, in business terms, the corner cases can be fixed at leisure. You, the product owner, stays in charge because you decide when to fix those things failing in the leaves of your supervision tree. And I'll speed it up now. Yes. Good. And that means that you actually here have software architecture that supports iterative development and lets you do the right risk management of when to fixing things. So if you want to cruise with Erlang, you understand the failure model, the golden trinity of Erlang. Please spread it. Yeah. You embrace failure, which is something that a lot of people have a very hard time doing, but that's what you need to do. And then you use the different patterns with supervision trees to deliver business value and make sure you're not chasing every little bug because it will take down your system. And that means you stay in charge and you continue to make money. Thank you.